Abby's going to answer 8 questions on a multiple choice quiz, and the probability that she gets any question correct is 0.75. Now, it says, what's Abby's probability of incorrectly answering exactly 2 questions on the quiz? So I've drawn 8 blanks here, put 8 blanks, and here's what we're going to do. We're going to let her get some of them right and some of them wrong. And I'm going somewhere with this. Let me tell you where I'm going with this and what my thought process was when I read this problem originally. I need to figure out the probability that she will miss 2 specific problems. And then I need to consider that those 2 specific problems could be in any position on here. So let's just assume that she gets everything right except the last 2. And then I'll expound on that idea a little bit more. So she's going to get number 1 right. So that's 0.75. And then she's going to get number 2 right. So that's a 0.75 chance of that. So the probability of getting number 1 right, probability of getting number 2 right, probability of getting number 3 right, probability of getting number 4, number 5, number 6. Now, she's going to miss 2 problems. Well, if there's a 75% chance she gets it right, then what's the probability that she gets it wrong? Obviously, 25. So here's what just happened. Abby's taking a quiz, and she's just gotten the first 8 right and missed the last 2. Now, this should look familiar because when we do this, we're going to multiply because she's going to get this right and this, and means multiply or means add. So we're going to do this right here, and just to save ourselves a little bit of time, 0.75 to the 6th power times 0.25 squared, and it's going to give us some answer, and we'll deal with that in a second. But before you grab your calculator, I want you to consider that that's not your answer. This is one way out of many ways that she can get 6 problems right and miss 2 of them. Because she could do correct, 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 wrong, wrong, which is what she just did. She could do correct, 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 wrong, correct, wrong. She could do correct, 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 wrong, wrong, correct. She could, and we could do this all day, right? We could do wrong, correct, 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 wrong. We can put them in all kinds of places, so the question really is, how many of these are there? Okay, let's finish this, and we're going to come back to this. We're going to tie it all together in just a second. So 0.75 to the 6th power times 0.25 squared. I'm going to use several decimal places just for accuracy. 0.0111237. We'll round it there. That should be sufficient right there. 0.0111237. Okay, that's the probability that this is the way her test is going to turn out. However, those 2 wrong answers could be in all kinds of positions on this thing. And knowing that, we need to know how many groups of 2 are possible from a larger group of 8. Okay, here's the question. We need to know, with these 8 questions, are the 2 wrong ones here, 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 and how many different ways can I pair them up? And I could have just counted them just then, but there's an easier way of finding it, and it's this. Now, the order doesn't matter, because I can have a wrong one here and here, or I could switch them and it'd be the same kind of idea. So I have 8 things, and I want to put them in groups of 2. Boy, I hope that looks familiar. This is going to be the number of ways that she can get 2 problems wrong and 6 problems right on this 8-question quiz. So we're going to figure out what that is. So 8C2 is going to give us 28. There are 28 ways this can happen. Well, this is the probability that it happens in one particular way, and there's 28 ways that it could happen. There's an easy way to solve this. Let's do it. 0.0111237 times 28. Not going to give you the answer at this point. I think it should be obvious. There you go.